In this question, the figure shown below has AC, the length as 13 units, angle ABC, that means this angle DCB, this angle, and angle BEC, this angle, all are of 90 degree, and all the sides of triangle ABC are integers. So we understand this is 13 to be the integer sides with ABC and AC being the hypotenuse. 13 square has a triplet of 5 square plus 12 square. So one side BC has to be 5, AB has to be 12, or vice versa. Now, importantly, let's say angle A is of value x. So angle A is x, then this angle will turn out to be 90 minus x. Now, if we talk about triangle BEC, angle E is of 90, angle C is of 90 minus x. So angle EBC turns out to be x. Similarly, if this is x, this angle turns out to be 90 minus x. So I can say triangle ABC is similar to triangle BCD is similar to triangle BEC. So AB, we have two cases when AB is 12, AB by BC equals to BC by CD. On this, we can calculate CD as BC square by AB, where BC square can take two values as 12 square by 5 or 5 square by 12. So there will be two possible cases that we can have with these two. So we can have two areas. So when we are talking about the area of triangle DBC, we cannot have a unique area, so the answer will turn out to be cannot be determined, as there will be two possible cases.